Hello everyone, and thank you all for joining us today. I'm Bob Crossan, Senior Managing Editor of Water and Waste Digest. On behalf of Water and Waste Digest and our sponsor, Evoqua, I'd like to welcome you to today's presentation titled Innovation in Dewatering. Learn how to reduce operational costs and increase sustainability with Rotary Press. We're going to get started here in just a couple of minutes, but first, a little housekeeping. You will notice on your viewer you have the ability to ask questions. We encourage you to ask questions, and we'll try to answer as many as we can at the end of the presentation based on time availability. Any questions we do not get to, we will answer offline. Our speakers today are Kurt Huber, Global Product Manager for Evoqua, and Ed Norfleet, Global Commercial Manager for Evoqua. And with that, I'd like to turn it over to our speakers. The floor is now yours.
Hello, everybody. My name is Kurt, and I'm a product manager over at Evoqua, and I'm responsible for our dewatering products. Really excited to be with you today because I get to talk about a product that is really near and dear to my heart, and that is the Evoqua Rotary Press. So today we're going to be giving you an introduction to that product. As we get going here, a few words to our agenda. We'll start out by talking about what is the Rotary Press and how does it work. From there, we're going to move on to talk about the basic specs. Then we'll talk about, hey, what's so great about this product? Why would I want to use it? Then we'll move into industries and applications and try to point out to you those jobs and those industries and applications where we think that the Rotary Press will bring you the greatest value add versus other types of solutions. And then we'll be wrapping it up with a Q&A session. So in just a moment here, we're going to start things off by showing you a video to show how the Rotary Press works. But before we do that, just a few words at a very general level about dewatering. So what do we mean when we say dewatering? And I'm sure that many of you know this. We're talking about taking sludge, which consists of both liquids and solids, and separating those liquids and solids out so that you can dispose of each in a way that makes sense and in a way that saves you money. And that's what the Rotary Press does. All right, at this point, we're going to pause and we're going to show you a video that gives you a good introduction to the system and shows you how the Rotary Press works.
Introducing the Evoqua Rotary Press, an elegant solution with few moving parts that simplifies the dewatering process. The Rotary Press requires little space and is easy to install. It offers fully automated operation, which is facilitated by an easy-to-use digital touchscreen. An adjustable feed pump delivers sludge into the press at the desired flow rate. Next, an emulsion polymer system dilutes and injects polymer into the sludge. This mixture is then pumped through the retention piping, where mixing and flocculation occur. The conditioned sludge is then fed into the filter screens to be processed. The water passes through the screens and is discharged via a gravity feed. The solids are trapped between the screens, forming a cake plug, which is then ejected out the chutes for disposal. This drier and lighter waste is much cheaper to dispose of compared to sludge dewatered with less efficient solutions. A lack of belts, bearings, and other high-wear components means little upkeep. And robust, low-maintenance filters are easily accessed through a side door, facilitating what little maintenance is required. Periodic wash cycles require only a fraction of the water used in belt presses, and the fully automated operation means that you can focus on what you do best and leave the dewatering to the Rotary Press. Contact your authorized Evoqua representative today for more information or to schedule a sludge analysis.
All right, hopefully that video gave you some good insights into how the system works. At this point, I'm just going to kind of summarize the functionality of the system. So first of all, where does it all start? It all starts at the intake where a sludge pump drives the sludge through the machine at a desired rate. And that is something that you can control by using the interactive touchscreen like you saw the operator doing on the video. Next, a polymer system dilutes the polymer with water and it injects that mixture into the sludge. And the mixture then flocculates as it passes through these retention pipes. You probably noticed when you saw the video that a section of those retention pipes is transparent, so you can actually see the flocculation taking place. Next, the mixture, once it's flocculated, passes into the channels, and that's where the filtrate is removed. The pressure drives the liquid through a screen, and that liquid or that filtrate is then ejected out of a drainage port. While that's happening, the solids also collect into a cake plug, and that cake plug continues to develop until it reaches the point where it overcomes a given pressure, and that pressure is something that you can control and adjust. So once that pressure or the back pressure is achieved, the cake plug is then ejected out of the chutes. Okay, so now we're going to say a few words to our specifications and the range that we offer. If you look at the matrix in front of you, you'll see a red box, a red rectangle, and those are the various sizes that we offer. So you'll note there a 6124, basically that means a 24 means inches, so it's a 24-inch product, and that 24 inches corresponds to the diameter of the screens. The 24 inches is the smallest. Then we also offer a 36-inch and a 48-inch. And so you'll notice that there are multiple configurations of each of these. You can take these different sizes and add channels to them. And of course, adding channels, what does that do? That gives you a broader range on your throughput. Now I'd like you to look all the way to the right of the matrix, and that is where we see our range. So our hydraulic flow range is all the way from 5 gallons per minute up to 260 gallons per minute. So those of you who are familiar with belt presses, that probably looks pretty familiar. A typical belt press range would be right in that hydraulic flow range as well. So from the standpoint of throughput, if you've been using a belt press, this could be something that you could probably use on those types of jobs as well. All right. Now we're going to get into talking about our value add proposition, and to do that, I'd like to hand it over to my colleague Ed. Ed is the global commercial manager for Evoqua for our dewatering systems. Ed, take it away.
Thank you, Kurt, for detailing the design and functionality of our Rotary Press. I am truly the dewatering geek in this group. I have owned, operated 4 different belt presses in my past. I've also provided contract operations for a number of wastewater operations through in the southeastern United States. As you can see on this slide, we're comparing 3 different continuous duty dewatering systems: the rotary press, the belt press, and the centrifuge. In cake dryness, the rotary press is best. It gives you a drier cake than the other 2, not by much, but when it comes to cake dryness, a percentage point or 2, or even 5%, can make a tremendous impact to the bottom line when you're paying for hauling and disposal cost. It is a major player, just those small numbers. Hydraulic throughput. As Kurt was highlighting, the rotary press can be customized to address a wide range of flows, all the way down to 5 GPM, up to 260. When you go beyond 260, we would have to have multiple machines to handle that. However, we can do that, and they can sit side by side and run and handle any flow that your wastewater plant generates. You see with a belt press, 20 to 150, and again with a centrifuge. Again, we're right in the mix of that. Capture efficiency. The only thing comparable to the rotary press is the filter press. They both have a capture rate of between 95 and 98% of the solids fraction of your sludge. Now, what does that really mean to you? Well, that means that we get it out the first time. It doesn't recirculate and go out with the filtrate and go back to the head of the plant to increase your cost of operations. It's recirculating over and over again through your facility. We get it out the first time. Now, operator oversight, extremely low. As we'll touch on in later slides, the rotary press really requires probably 20 to 30 minutes per day of operator attention. A day, That's amazing. The operator is then free to go do whatever is necessary to operate the plant efficiently. Let the rotary press do what it does. It'll run by itself, dewatering your material. Noise, very, very low. You can stand beside a rotary press and have a regular conversation at a regular volume. You don't have to scream. You're not going to be sprayed with overspray. It just runs very nicely and quietly and generates cake on a continuous basis. Polymer consumption, extremely low. I personally have never seen a machine that consumes so little polymer and delivers such great throughput. I think it's a tremendous option in this point. Now, when you get down to the other areas, now you're talking about those sustainability areas. Electrical consumption. Again, as Kurt highlighted, it turns a very slow speed. By turning at a very slow speed, it consumes very little power as compared to a belt press. Also turns slow, but has usually a number of motors that it has to power. The centrifuge, it's going to be pulling a lot of power consumption because it's turning at a very high speed. Water usage, think about this. 6% of the belt press. 6% as compared to the continuous flow and water usage of a belt press. That is amazing. In the areas of the western states where they're really in drought conditions, this is an incredible device. Next. Now, in an 8-hour day, a belt press will consume enough water to fill a 20 by 40 foot swimming pool. And the water is not as clean as what's in that swimming pool. It's actually being run back to the head of the plant to run through the system again, taking up plant capacity. When you're taking up plant capacity, you have to allow for that, and you have to have a bigger plant to handle the same load. That is inefficient. Next. Size, footprint size of the equipment. This chart is extremely clear to see. A rotary press is roughly a third of the footprint of a belt press, and even a lower comparison to a large screw press. The difference, though, is that what does it take to support that equipment? People never talk about the steel, the concrete that's needed for that building, for the dewatering building. Well, for a rotary press, it's going to be a pretty small building as compared to the belt press and screw press. And when you think about it, a belt press typically has a separate polymer system and a screw press as well. The rotary press, as you saw in the video and in Kurt's conversation, it has its own built-in polymer system. It's all there, compact, ready to roll. Next. Value proposition. Now, this isn't the value proposition for us. This is the value proposition to you, the operator. Think about it. Automated startup. We say automated, but really it requires 20 to 30 minutes a day to get the system up and running, make sure the flock is right, make sure everything's running smoothly. Then walk away, run the plant. You no longer need an operator standing there watching the machine go round and around and watching cake come out. This system runs itself. You can go and do everything you need to do to keep the plant running properly. Automated shutdown. At the end of the day, let's say you want to end the day at 5 o'clock with the rest of the labor force. It'll shut itself down. It'll go into wash mode, and it'll be standing on standby waiting for the operator the next morning. You don't have to have someone there to turn it off, to wash it down with a hose or anything else. It shuts itself down. If there is a fault, maybe a pump coming out of the digester feeding the whole system trips. Well, if that happens, the rotary press will alert the main control room. It'll shut itself down, go into wash mode, and be on standby, waiting for the operator to come back, clear the fault, and get it up and running again. This is a huge feature. You don't have to worry about belts shooting off to the side and ripping and tearing. You don't have to worry about any of these things anymore. It just shuts itself down and waits for the operator. You'll also have the ability to custom program the machine for the operations of your plant. Maybe you have to run your plant and dewater because of flow requirements or restrictions. Maybe you have to operate in very short windows, 24 hours a day. This unit can do that. Or maybe you want to run continuously on a 12 or 18-hour shift. It can do that too. You just have to customize it and program it for what you need in your facility. Next. This is my favorite slide. Anyone that's maintained a belt press with all the different parts and pieces and so on that go wrong can look at this and go, wow, that's all the parts that are needed. That's it. And they can all be maintained with just hand tools. You can break it down, replace the seals, the gaskets, whatever's needed with hand tools. You don't have to send out for a special technician, although if you need us, we will be there. You don't have to have all these things. Because of the low rotational speed, it's not going to wear these parts out. It doesn't have any internal bearings. It doesn't require complete machine rebuilds. Now think about that from the standpoint of cost and downtime. This machine, probably 30 minutes to an hour once a year, keeps the machine running at a peak level. Whereas, think about the cost of just replacing the belts on a belt press. Could easily be $1,000 just to replace the belts. And that doesn't include the labor to feed them through, put them back in, pull out the old ones. That $1,000, you will not spend that $1,000 on a rotary press in 5 years of maintenance. So think about the difference in cost savings and uptime and simplicity in your operation. This is where these things really pay off. Next. Targeted applications. When do you use a rotary press? Well, next. Here we're going to compare the rotary press to the filter press because they really are unique individual systems. The filter press is a batch system. It will get you by far the driest cake in the industry due to the pressure it puts on the cake material. There's no question, nothing can touch that. It has an extremely high capture rate. Again, wonderful. The negatives are it's a batch system. Been around forever, and everyone knows you have to have labor involved to clean out the chambers every time you open and every time you get ready to run a cycle again. Now, we've added new automation in the recent years, and it's gotten much better, but still requires some level of labor operator being involved. Now, you go to the rotary press. It will not get the cake as dry as a filter press. However, it will be usually drier than its competitors. It will run continuously. It will not require labor involvement, and it will just generate good dry cake continuously 24 hours a day if you needed to. Now think about that. It really is an amazing machine, and it fits the various applications that are out there. Next. Here, we've basically outlined pretty much every wastewater sludge we could think of. Ag, food, bev, muni, power gen, mining, manufacturing, oil and gas. Between the filter press and the rotary press, we feel confident that we can address virtually every wastewater sludge that's out there. Now, yes, some are better, some are worse. In many applications, we would come to you and recommend the filter press. Matter of fact, that just happened on our project. After running the analysis, the client really wanted the rotary, but we had to say, no, it's really going to be best for your operation to go with a filter press. Now, the rotary press is a great system. Handles all types of different organic waste streams, different types of systems. You see the yellow lines, that's a cautionary thing. It's not perfect for everything, but it still addresses a wide range of materials and sludges. Next. Here, let's say you're not sure. You're trying to make a decision on a capital purchase as to what's going to be best for your operation. Please send us a sample. Put a sample of your sludge in a bucket, send it to us, our lab tests are free. We will run it through both the filter press test and the rotary press test. We will come back to you and say which piece of equipment will best fit your operation. Then we will tell you what chemicals we had to add, whether it be a polymer or a coagulant, to achieve the highest optimum result. Now, that's pretty good considering it's free. Now, the best part about it then, now let's say you go, well, the report looks good. I think I really need to go with the rotary press, it's best for my operation, But how do I convince my management? Call us. We can send you a pilot unit or a rental unit. You can rent it for a while. Everyone can come and see. You're absolutely assured that this is the product, by looking at it, running it on your material, that it will be the best for your operation and your facility. There's no questions asked at that point. It's an optimized operation. Next. In summary, the Rotary Press is highly efficient, highly effective dewatering solution. We touched on the cost effectiveness of the unit. We've had both outside engineering firms and our internal analysis say that it will pay for itself in 3 to 4 years. Think about that for a minute. Pay for itself? How? In savings in OpEx. If your cake is drier, you're not going to be hauling as much to the landfill. You're not going to be paying as much in landfill fees. You're not going to be paying as much in power consumption or water usage. Your chemical usage will be down. Your labor consumption will be down. It will pay for itself in savings to your operation. And the simplicity of the unit makes it an absolutely incredible opportunity for your operation and simplify what's going on at your facility. It works well in many organic sludges, municipal water as well, and then food and bev industry. It is designed for small to medium plants, but with multiple units, we can also handle larger facilities as well. When you have any questions, please call us. We'd love to talk to you about it. We feel it's an absolutely great piece of equipment for the industry going forward. Now, if you have any questions, please. Thank you very much for your time.
Okay. So let's get into our Q&A then. I will say that we do have another professional from Evoqua joining us. That is Carrie. Carrie, if you wouldn't mind introducing yourself so people know what you do with Evoqua, and then we'll move into the Q&A.
Yes, good afternoon, everybody. My name is Carrie Gabriels, and I have been working for Evoqua just over 7 years. And I run the dewatering laboratory, which is to say that I do all of the testing for equipment selection and sizing for filter presses and for rotary presses. We are a lab based out of Holland, Michigan. And so we will do feasibility testing on applications and then following that up with the sizing of the equipment, some chemical selection, polymer selection, those kinds of things.
Cool. All right. Well, thank you for joining us for the Q&A. I'll start with these two. They're similar, probably can be answered kind of at the same time. One was, how dry is typical sludge cake? And then the other was, what solids by weight is typical of the sludge cake?
Yeah, so typically the applications that work best on the rotary press with the municipal applications, they're biosolids, and you're expecting somewhere right around 20% of for the filter cake, solids by weight. And the feed solids are typically somewhere around 1 to 5%. It can go higher. We technically don't really like to go any under 1% feed solids, because then it takes time to accumulate the cake in the chamber.
Okay, cool. Now, there was mention of polymer as well in this. Could you speak a little bit to the polymer there? Is that a proprietary Evoqua formula, or can a facility utilize the polymers they're already employing in their flocculation process?
Yeah, so the rotary press requires a very good stable flock, which means that it's not going to break apart under any of the differential pressures caused by the cake creation. And so a lot of times we will do benchtop feasibility in the lab to select the polymers, or we can use, existing known polymers that are known to flock the material. And that's not, Evoqua does not sell polymers, so we will work with any polymer vendor that is available to have set up on site, recommend any polymers or treatment chemistry in general. Upstream of the rotary press, but the chemical injection system is all done on the press in line with the sludge. And so, yeah, we can help with the selection of that polymer and dosing and all of that.
Yeah. Oh, that's great. I imagine for some utilities that already have like a process in place, they already have their supply lines for their polymers and flocculant. Having the ability to be like, does this work with your equipment? It's got to be really
Yep.
useful.
Yep.
So
That's
could you
correct.
talk? Sorry, could you talk a little bit about the flock tube? I have a question here. How often does the clear flock tube have to be cleaned?
It depends on every application. So the rotary press itself has, like I said before, the polymer injection system in line with your sludge, and the clean in place system can be run continuously with sludge, or after you're done for the day, it can, run on an empty chamber or full chamber. And that is dependent on the site specific when you need the press to be cleaned. I don't know that there's a set recommended timing on that one.
Okay. Now I wanted to touch on some of the industries here. We got a couple people asking about what I would imagine are their particular industries. One was, do you run pilots on industrial sludges for food and beverage? And then another was asking about the electroplating industry. Could you speak to either of those industries and how this would fit in there?
Yeah, so industrial wastewater is kind of difficult, like I mentioned before, trying to get the treatment chemistry with a flock that is stable enough to hold in that chamber. If the flock doesn't stay put with the solids, then all of the solids are going to push through the screen on the rotary press. So we would really, on industrial applications, prefer to do the lab testing in lab. It requires a very small amount of sludge sent in, maybe only a gallon or two sent to the lab, so that I can do some bench feasibility and polymer flocking, and then do that here. We do have a couple of rental units that were run out of here, but the pilot units I just use in the lab here. I don't send those out to site just yet.
Okay. And I will say that there was a question as well about rental units and whatnot. They provided some information in the question period. So we'll make sure that you can get that so you can answer their question a little more directly. Are there any limits on the inlet concentration for this?
Yeah, so the rotary press is actually, each individual size is selected based on a flow rate and a solids loading. So dependent on how many solids that are in the sludge stream, sometimes all that means is that the flow rate needs to be back down so that you're not running on max capacity for the machine itself. So it's kind of a either or, and it's a very difficult question to answer just off the fly. It's got to be calculated with both of those two factors, which we can help with once we have the information.
Okay. Is there any specific solids percent of the sludge that should be fed into the rotary press? It seems like you were kind of touched on that a little bit in that previous question as well.
Yeah, typically the sludge solids should be between 1% and 5%. I've had some sludges that are 10% that work as well. It just, like I said, it really depends on the flow rate and the amount of solids you have per day so that we can get the right equipment for that. Some of the larger machines can handle more flow rate and more solids loading. And the smaller pieces of equipment obviously are going to handle less.
Yeah, cool. Wastewater treatment discharge. So I'm going to read this question verbatim, and maybe you can help me understand it a little bit better. Wastewater treatment discharge in place of filter press off inclined clarifier? Question mark.
It depends on the solids that are being fed into it. Yeah, because we get a lot of clarifier wastewater, and it can mean a lot of different applications. A lot of different applications have clarifiers in them. So it really truly depends on the application that is being sent to the clarifier.
Cool.
But yes, your sludge stream could come from the clarifier and be treated in the rotary press from a clarifier.
Got it. How do you keep the screens clean? Are screens considered to be a wear part of this system?
The screens themselves, they are 304 stainless steel, so they typically last a very long time. and that you can have your clean in place system set up for as frequently as you would like it. The spray nozzles are they spray from the back side of the screen, so from where the filtrate comes through, so you can be spraying that at the same time as you're running sludge. You're just going to get a little bit more fluid out, a little bit more water out, possibly a little bit more solids in the filtrate when you're doing the cleaning run.
Got it. What is the typical density of rotary dewatered solids?
That I don't know offhand because of it's the application question. So the solids that biosolids are a lot more light and fluffy than some of the industrial solids are, so they're going to have different weight. I'm used to just telling customers as far as the cake discharge, it's generally around 20% feed solids 20% solids by weight.
Got it. Is the rotary press sensitive to flock shearing?
Yes, it is.
Okay. And how much water?
I keep mentioning good.
Yeah, sorry. I'm so sorry for talking over you. Go ahead.
No, I was just saying that so that's why it's really important to get that treatment chemistry down at the beginning of the cycle. And once the treatment chemistry is set and the first bit of cake starting to be produced out of the chamber, then it should be able to run all day long with minimal monitoring.
Okay. Another one here. How much water would I expect to go through in a day on average using the rotary compared to my 1.5 meter belt press?
I don't know the exact answer to that one because it depends on the size of the rotary press. And I am actually not that familiar with the amount of wash water that would go through. But with if they're referring to the amount of sludge that they will process, it's dependent on the size piece of equipment that they have.
Got it. And could you talk a little bit
about?
Yes, I am.
Would you mind clarifying that a little bit, that last question?
Yes, so as Carrie was saying, it does, of course, depend, but we can also provide some kind of ballpark estimates. If you're looking at, let's say, an average size rotary press, which for us would be our 36 with our 36 dual. Every hour, we recommend doing a brief cleaning, and then at the end of the day, we recommend doing a brief cleaning, and that's part of the automatic shutdown process. But all in all, you would be looking at something like a few thousand gallons versus something like 28 or 30,000 gallons for a belt press. So all in all, we say it's in the neighborhood of 6% of what a belt press would use.
Cool. So you had mentioned there some of the maintenance elements of the cleaning, kind of beginning and end of day. Could you talk a little bit about the maintenance required and how often that would need to be done?
Yeah, sure. I can take that one. The rotary press itself can be run continuously. However, we do recommend that, as I said a moment ago, once an hour that you go through a brief cleaning process. We do recommend at the end of the day that you go through a brief cleaning process. In terms of actual maintenance that you would be performing, the thing can pretty much run 24/7. It doesn't have, of course, the belts that you have with a belt press or the scrolls and bowls that you'd be replacing with the centrifuge. So what does it have? Really, there's a set of brass scrapers within the units. Those things have a life of about 5,000 to 10,000 hours. So depending on how much you use it, it could be a year, could be more than a year. And to replace those, we're talking about using just hand tools and probably just a few hours to get that done. Beyond that, there are a few gaskets and things like this. The oil change, I think, in the pump would need to be replaced probably every couple of years. So very, very minimal maintenance. You might be looking at something like a day within a year for your maintenance requirements, which of course it's going to vary depending on use.
Yeah. Now, obviously, you want to do the maintenance so that you can improve the lifetime of the actual unit itself. Could you just speak to the lifetime of the press, how long it can run before an overhaul or a replacement?
So all of these things vary, of course, pretty significantly with how they're being used, but they're designed to use and would be expected to endure for decades.
Got it. And you've said this a couple of times that you can run this pretty much constantly. Do you still need to shut it down? It sounds like you do for minimal periods if you're going to be doing a little bit of maintenance here and there.
Well, of course, we do recommend that users go through the cleaning process periodically, and that can be programmed into the device using your interactive touchscreen. But beyond going through these occasional cleanings, you can pretty much let it run with minimal supervision.
Cool. We're still getting questions, so I'll keep asking them. We got still to the top of the hour. So, do you have any applications on lime softening sludge from a water treatment plant? Are there any concerns with polymer in regards to beneficial reuse land application?
I don't know, Ed or Carrie, you might be better able to answer that one.
Yeah, I would say again, go ahead, Ed.
Okay, I was going to say there are installations using the technology in lime softening sludge. We personally do not have it, but we do know that there are indications that it works fine. But with regard to polymer and land application, I used to actually do a lot of land application, and polymer was never an issue. I know that certain states have their own regulations that need to be addressed, but I don't anticipate that polymer is going to be an issue.
Got it. In multi-channel systems, can you service a channel without turning the other channels off?
It's designed so that you can service it, but obviously if a channel is on the outside, it's going to be easier to maintain and access than one of the inside channels. That's where things become a little awkward.
Okay. Got a couple more here. What is the screen opening size?
Carrie, do you have that information?
Yeah, I do. So the screen itself is tapered. So the cake facing side is somewhere around 300 micron. And the back side where the filtrate gets discharged is around 400 micron, a little bit bigger than that. But I'm just going to use rough estimates because I don't have the exact numbers in front of me.
Got it. Okay. One second, looking for another one here. During startup, do you need to divert the discharge cake until the plug is formed?
Yeah, I'll take that one, Ed. Maybe you can expand on it. You do. So when you're setting up and you want to make sure you got your chemistry right and you're flocculating properly, and during that time you do want to run it in such a way that you're not running through to the channels. You can run in bypass mode, which is actually default mode when you set it up. And so when you've got your chemistry right and everything's flocculating properly, then you shut the bypass mode off and you put it directly into the you send it directly to the channels.
And then once it's in the channels, then that material will flow to the plug and start driving through the unit.
Understood. Understood. Can non-potable water be used for the wash water?
That really comes down to the quality of that water. Offhand, the answer is yes. But we really need to make sure that the particulate size and so on is small enough where it's not going to clog any of the jets, the spray nozzles.
Yeah. Okay. Can you speed it up or slow it down while operating?
So we're talking about speeding up and slowing down. So those are inputs into the touchscreen that you can adjust. I've never tried doing that.
Right.
But I would think that it could be done. You know, the speed, the operation is yeah, I would think that it could be done, but I've not tried it.
I mean, it is
Got it.
designed to run continuously, so that once you start it up, it's rolling, and you really should not have to address that during the day, but maybe if there's an upset, you may have to come back and do that.
Okay. It looks like the last one here. Would sludge from wet precipitator common in foundry? I'm not entirely sure I understand the question, but speaking to wet precipitators common in foundry, does this unit handle that application?
I would say that we'd love the opportunity to test it in the lab, because before it's approved by Carrie, we would have to say no.
That's totally fair.
She's going to have to say yes or no. Yeah.
Yeah. Well, and that's why you have a lab, so you can test all this stuff out and be like, it works. You want to make sure that you're giving them the right thing too, right? You mentioned the filter press versus the rotary, and how you want to make sure that you're getting the right equipment into the right application.
Right. And again, the testing is free. It's really just the cost of the shipping.
Yeah. Great. Well, thank you guys for your time today. We really appreciate it. And everyone who's listening, we also appreciate you coming and being so engaged and asking so many questions about this technology. So for everyone who's watching, you can revisit this webinar from the URL that you used to log in today. You can also share that exact link with anyone that you wish who would also be interested in attending this webinar. All they have to do is fill out the registration form, and they get free access for the on-demand version of this webinar. And with that, that concludes our webinar today. Thank you so much for everyone who is here, and for the speakers for sharing your knowledge.